In lesson 14.2, you will translate and reflect trigonometric graphs. And our first graph is y equals 3 plus 1/2 the cosine of pi x. Our cosine function with all the translations and reflections considered will look like this. So this graph is in the form y equals k plus a times the cosine of bx. And that k value of 3 is going to cause a shift in that horizontal axis or midline from the x-axis to y equals 3. And that a value is going to give us our amplitude. Our amplitude is the absolute value of a, and the absolute value of 1/2 is 1/2. So we have an amplitude of 1/2. And for this cosine wave, we have a period of 2 pi over the absolute value of b. And b happens to be pi, so the absolute value of pi is going to be pi. Pi's cancel, and this period simplifies to just 2. So now, knowing this information, we can build our graph. We'll label our axes. And we have a period of 2 units, so I'm going to go 1, 2 along the x-axis, and -1, -2 to the left of the y-axis. Okay, and then we have a new midline or horizontal axis, so I'm going to sketch in y equals 3. Okay, now for a cosine wave, it's going to start above its horizontal axis on the y-axis, the height of its amplitude, which is 2. And then it's going to travel 2 units, the distance of its period, before it starts over again. Halfway in between, it's going to reach its low point, 1/2 unit below its horizontal axis, and halfway between those halves, it's going to cross the horizontal axis or midline. So here's the wave, or one cycle, of this cosine wave. Now we can repeat it in the other direction. So let's find those points again. And we'll fall to its low point and rise again. There's 2 cycles of this cosine function. Okay, here we have a sine function, and it's of the form y equals a times the sine of b times x minus h. Okay, now that h value is -pi/3, and that h value is going to cause a shift left or right. Because it's negative, this shift is going to be left pi/3 units. The amplitude is the absolute value of a, and a is 4, so the absolute value of 4 is just 4. Period for this sine function is 2 pi over the absolute value of b, and b is 3, so 2/3 pi is our period. Okay, we're ready to graph again, knowing this information. So on the coordinate plane, there's no shift in our midline or horizontal axis, so that'll be the x-axis. We have a period of 2/3 pi, so I'm going to go 1, 2, 3, and mark pi units, and I'll go 1/3, 2/3, 3/3 in the other direction and mark pi units. Okay, so now we're ready to build our sine function. We know that the sine wave should start at the origin on its horizontal axis, the x-axis, but because of that shift left pi/3 units, it's going to actually start here. at negative pi over 3. And then it's going to travel 1/3, 2/3 pi units before it starts over. The sine function will cross the horizontal axis again halfway in between its beginning and ending point, and in the first half it's going to reach its height, the height of its amplitude, and in the second half of this cycle it's going to fall to its depth of 4 units. So it's going to rise and fall and start over. So let's build another cycle to the left here, just repeating that pattern where it falls to its depth and then rises, okay, as it moves to the left. And then let's do one more cycle. So we'll put our points in place. It's going to reach a height of 4 units and it's going to fall to a depth of 4 units as it waves along this x-axis. So there's 3 full cycles of this sine function. Okay, here we have another cosine function, and it's in the form y equals a times the cosine of bx. Now that a value being -1 is going to cause a reflection in the horizontal axes. Okay, and a is also going to give us our amplitude for this cosine wave. The absolute value of -1 is 1, so we have an amplitude of 1. We have a period of 2 pi over the absolute value of b, and b is 4. So 2's are going to cancel, and we can simplify our period to pi over 2. Okay, now we have enough information to draw our graph. And we have an amplitude of 1 to account for. We have no shift in our horizontal axis and no shifts left or right. We're going to travel pi over 2 units before we start over. So let's label our x-axis pi over 2 and pi. Okay, left and right. And now the cosine function, again, remember, should reach its height above the horizontal axis on the y-axis, but because of the reflection it's actually going to go the other direction. It's going to reach its low point below, 1 unit below the horizontal axis, and then it's going to travel pi over 2 units before it starts over. Okay, halfway in between is going to reach its height above that horizontal axis, and halfway in between the first half and the second half it's going to cross the horizontal axis or midline, which happens to be the x-axis. Okay, let's build another wave or cycle to the left of the y-axis, and we'll rise and we'll fall, and we can continue that in both directions as far as we want. There's 2 cycles of this cosine wave. Okay, next we're going to graph a tangent function, and it's of that same similar form. Here, I'll circle it. So what we have is y equals a times the tangent of x minus h. Okay, and that h value of pi over 2 is going to cause a shift left or right again, and this time it's going to be right pi over 2 units. Okay, and that a value of -2 is going to cause a reflection. When it's negative, it's going to cause a reflection in the horizontal axis. Now there's no k value shifting our horizontal axis, so it's going to stay the x-axis. And there is no amplitude to worry about, but there's a period for this tangent function, pi over the absolute value of b, and b happens to be 1. So our period is just pi units. We have those vertical asymptotes to put in place. And the vertical asymptotes are going to be found at pi over 2 times the absolute value of b, which was 1. So pi over 2. Odd multiples of pi over 2. Okay, so now we can go to the coordinate plane to graph this tangent function, knowing the information that we've gathered. And because there's no amplitude, we don't have to worry too much about our labels along the y-axis. They should be there, but we don't have to be too concerned. And our period is pi units, so I'm going to stretch this out along the x-axis. Okay, and then we know that our asymptotes would be the first thing we'd put in place, and they would be at odd multiples of pi over 2, but because there's that shift right, pi over 2 units, I'm going to move that asymptote right, pi over 2 units, 1/2 pi unit, and I'll build my first asymptote here. And now my period is pi units long, so every pi units, I'm going to have another asymptote to put in place for this tangent function. And then halfway between those asymptotes is where it's going to cross its horizontal axis or midline, and in this case the x-axis. Okay, now remember it should rise from left and right, but because of that reflection, it's actually going to follow those asymptotes, reflect at its midline, and fall from left to right. We have that reflection to account for. So here's 4 cycles, 4 periods of that tangent function. Include with your notes of this video guided practice problems 2, 4, and 6 on pages 917 and 919 of your textbook.